So walking through the warm-up today,
Yeah.
our first sequence, 2 to the n over n cubed. If you find a sub 4, you get it by just plugging in a 4, right? So you get 2 to the 4th over 4 cubed, which is 16 over 64, or 1/4. Word that all your test problems were like that, right? Oh, what a world. Okay, so number 2, s sub 4, that's the sum of the first 4 terms, right? So to find s sub 4, I needed a calculator, right? So the total, when you add all 4 terms together, you get 329 over 108. Did everyone okay with that? You need me to walk you through it? Uh-oh, a look of distress.
My calculator is weird, but we can address that.
You sure? Yes. Okay. Okay. All right. Let's see. The next one. Does a sub n converge or diverge? So it's asked about the sequence. The sequence converges if the limit exists, right? And diverges if the limit doesn't exist. For this, does the limit as n approaches infinity converge or diverge? Exist or not exist? It diverges. And how did you figure that one out? Comparative growth rates, right? You have a exponential over a polynomial, faster over slower goes to infinity, right? So the sequence diverges, and here's a nice little perk. If the sequence diverges, then the series diverges automatically by nth term test, right?
Oh.
Yeah. So that makes life really easy.
Can't you also use the root test?
You could use the root test, but I'm not. That would be tricky because you'd have 2 over n to the 3 over n.
Well, can't you break? I mean, this n is going to infinity.
Yeah, but you're doing the limit as n approaches infinity.
Well, that would be infinity to the 0, which is just 1.
No.
I wouldn't try it. Let's just go with the nth term test.
Infinity to the 0 is determinate.
Yeah.
Wait,
All right. Okay, so the next one,
Infinity
alternating
to the
series.
whatever.
The alternating series converges if you ignore the -1 and just do the limit. Just telling you now, it's one of those days where I have to do the tapping. If you just do the limit of a sub n as n approaches infinity, if that limit approaches 0, then the whole series converges. If it doesn't, it diverges. This one, again, doesn't approach 0, so therefore the alternating series also diverges. And because the alternating series diverges, question 6 for part A is moot. Moot. Is it moot?
Boot?
Moot, like what a cow says with a T on the end.
Like,
Yeah.
No. I'll say boo.
Yeah, she says moot like every day.
I do. It's not the first time. I love the word moot.
When have I ever heard you say it?
Really?
I've never. You
I
might
never
not
heard
have
you
heard
say it.
her, but she has said it.
Moot means
Because
irrelevant.
she said it twice
how many
yesterday.
O's?
2, or as many as you'd like,
What does it mean?
right?
Irrelevant.
It means irrelevant. Question 6 is irrelevant because the series diverges, and therefore how are you going to find?
How do you think that makes it feel?
Yeah.
It feels irrelevant.
Hopefully irrelevant.
Or moot.
Are you saying that Are you saying that
Moot's the
series?
cheapest calculus. Go ahead.
So are you saying that series doesn't have feelings?
Yes.
Wow.
Moving on. Part B.
Wow.
So, part B, we plug in a 4, right? So you get 11 over 20 for question 1. For question 2, finding s sub 4. There we go. To find s sub 4, you're summing the first 4 terms. You should get 149 over 30. All right, for question 3, does the sequence converge or diverge? This one, you have a higher degree on the bottom, so the limit's approaching 0, so the sequence converges. The series, you still have to check. Just because the limit approaches 0 doesn't necessarily mean it converges, right? So you have to use another test of some sort. Any idea, this is a tricky one, any idea of a good test to use? Yes.
Limit comparison.
Hey, that's what I used. Yeah. Okay, limit comparison is a good test to use for this one. Not many tests serve you well for this. The ratio test is inconclusive. The root test doesn't really work well. So you're really down to, obviously it's not a p-series, it's not geometric, the n-squared test already failed. So we're down to the integral test, the direct comparison test, the limit comparison test.
Could you do partial fractions with the second one, and then?
You could, and see if it's telescoping, you could try that too. I did it by limit comparison, but you are welcome, if the denominator factors, you could also check for telescoping, right? So, you'd have to check and see. All right, so everyone, if you haven't found it yet, I want you all to take a minute and see if this series converges. I did it with limit comparison tests, but that's up to, that's what I did. So the way that I did it, I think I dropped the 3 in the end and did 2n over n squared to compare it. Which just simplifies to 2 over n. Oh, I'm so sorry.
It's not.
Spoiler, but you still have to apply the test. Why do you apply it?
Or you could just check that if it was less than the function.
Job test tomorrow.
Right.
It's not that bad.
How hard was the true and false
It
section?
wasn't. I thought that.
For somebody like me,
It doesn't matter.
it's
Yeah,
gonna.
how hard was
Gives
the
you
true and false
100
section?
points.
There's no true and false section.
Okay, good, so it's only 60 questions?
Okay,
I want
let's
true or
focus
false,
on this
I want
problem.
true and false.
Thank you.
No, true and false are
And
so.
I think I've already made the rule.
Yes, they are. Dude, they're like the worst things in
Last
the
test I
world.
Unless
thought,
it's
The first test he had 25 true or false and 16
One of them was like,
and then true or false like wrecked everyone.
All right, Shreyas, can we all focus on the problem at hand? Thank you. Gentlemen, problem at hand.
Yeah, I should.
You have to find a function that's similar, but simplified in a way where you could easily determine convergence. Like 2 over n, right? So I compared this.
Yeah, you could.
So this is a sub n, so I let b sub n equal 2n over n squared. So it's similar, I just killed off the 3 in the end. And then this simplifies down to 2 over n. 2 over n, does that converge or diverge? How do you know?
P-series.
P-series, right? This is a P-series where the power is 1. Remember, anytime the power is less than or equal to 1, it diverges for a P-series, right? So we know this diverges. To apply the limit comparison test, I don't know if I did it in my notes or not, but you just take the limit of one divided by the other. It doesn't matter which one's on top, which one's on the bottom. It makes no difference, but you do one divided by the other. And then for the limit comparison, for the limit comparison test, if the limit exists, that doesn't mean they converge, it just means they match. So for the limit comparison test, as long as you have a limit, and here's, I saw P test and it's freaking me out. Okay, so as long as you have a limit, and remember the limit has to be finite and positive, right? So as long as the limit exists, right? If the limit exists, then they match. And since 2n over n squared diverges, the other series also diverges. All right? I saw some frowny faces. There's a lot of tests that use limits, and it's really easy to get them mixed up. So that's one of the goals for today, is to kind of make sure we're all clear on which test does what, when to use each test, and what the results need to be for each test. That's what today is for, is just kind of one last test summary day before we jump in tomorrow with Taylor polynomials. Yes?
So when you say that the limit does exist and it's positive and finite, what does that tell you?
That the two functions match, whether either both converge or they both diverge.
Okay.
So that way, like whatever one you picked should be one where you knew the answer. Like this one, I know this diverges, so therefore because my limit works, this diverges as well.
Okay. And you just said greater than 0 to prove that it's positive?
Yeah.
That doesn't have to do with convergence at all?
It has, technically your limit has to be finite and positive,
Right.
right? So it's finite.
But if
and
it
it's
was like
positive.
half or 1, it wouldn't matter as long as it's.
Yeah, it
Okay,
doesn't matter what the
okay.
answer is. Yeah, it could be 22, yeah. Yeah, the number doesn't matter as long as it's finite and positive. Okay. All right, so, alternating series test. So the next question is, does the series, if you had a -1 to the n in front of a sub n, does that converge or diverge? Remember, for the alternating series test, all you have to check for that is, does the limit of the series without the -1 approach 0? If the limit of this approaches 0, then the alternating series converges. Right? So this one, yes, the alternating series converges. To figure out which, the value of n so that the sum is within 0.1 of the true sum, how would we do that?
Put it in your calculator.
And then look
Put in
at
your
it.
calculator, find which term actually literally is less than 0.1, right? So you go to the table and you scroll down until you hit the first term that's less than 0.1, and the sum of all the previous terms will have an error that's less than 0.1. All right, so in this one, it ended up being the 21st term. So you wanted to sum the first 20 terms to get an error less than 1. Is that okay? Lila, you look amused.
I'm good.
Are you? Okay. Yes, Doug?
So if you just did, like, if you're just supposed to write down the n on this one instead of like writing s sub 20, would you put down 20 or 21?
Let me see exactly what it asked for. It said, find n so that s sub n in the alternating series is within 0.1, so your n would be 20.
Okay.
Yes.
Are all of our questions on the test up till section 9.6 just find whether or not the series or sequence converges or diverges?
There are 3 types of questions from 9.1 through 9.6. The first section is, does it converge or diverge? The next, there's a section that says, find the sum, which would be for geometric series and telescoping series. And then there is another section that you could do, that has to do with error.
And
This
how many
stuff.
questions would that make up?
I don't know.
Alright.
Half the test.
One each.
2/3. Probably about half the test. So, all right, good. Any other questions before we move on? It's time to play Name That Test, all right? I actually decided I want to change this though to, I'm going to rename this to Which Test is Best? Because it rhymes, right? Okay, so.
The test is right.
All right, here is my homework.
No.
Everyone's
Is that
okay?
Brian?
Nope, I'm fine.
Okay. So, okay, quiet down, let me get your attention, gentlemen. I've lost you, but I want you back. Feeling you back. Okay. At the end of this lesson, I want you to be able to look at a series and have a very solid idea of which test to use to determine convergence, right? There are a lot of series where it's very straightforward and automatic which test to use. But then there are some series where it's kind of not quite sure, right? It's not quite as definite. Those are the ones that can get a little tricky. The other thing I want to make sure that we walk out with today is a fairly solid understanding of how to apply each series, or each test, right? So that's the goal for today, those 2 things. How to know which test to use, and then how to apply each test. So we're going to walk through those 2 things both today. By the way, don't forget there's a homework change. So last night you did through 49, so tonight you start at 51. And then I think it goes to 67.
Yep.
So, there you go. Okay, yeah, it's very short tonight. But, and I'm real serious about this, don't take this lightly. There's very few problems in your homework tonight. I really want you to truly think through each one carefully, So it's not just a matter of sticking a converge at the end, like writing down the problem and taking a guess. I want you to actually do the math. If you have to apply the integral test, I want you to apply the integral test, right? If you have to apply the alternating series test, I want you to apply the alternating, I want you to really do these, because it's only through practice you're gonna learn them all, right? So, okay. All right, so the first thing I did was I just made a quick list for the quick ones. These are the kind of what I call the quick series tests. So, ones that are kind of easy to recognize. So the first thing you should always check, and it's always the most forgotten. The first thing you should always check, if you look at a series and you're not positive how to approach it, always start by the nth term test, right? Always start with it. Because if that limit doesn't go to 0, automatically diverges and you're done, right? A lot of the ones where you're not sure actually work with the nth term test and they're really easy. But people forget to use it, right? So don't forget the nth term test. All right, the next one that should be really easy to recognize is geometric series, right? You have a number to the nth. If there's a coefficient, that's fine. It doesn't matter. For any of these, coefficients are irrelevant. You can put them in front of the sum, right? They don't matter. It's the r to the n that's important. That r, of course, for geometric series, the absolute value has to be less than 1, right? For it to converge. Okay, good. All right, so if you have 1 over n to the p, so now n is raised to a number. So here you had number to the n, that's geometric, n to a number, right? That's your p-test. But it has to be 1 over, n to a number. That's your p-test. Remember, for p-test, if p is greater than 1, it converges. If p is less than or equal to 1, it diverges. All right? Okay, so far, this one's really easy to recognize. This one's really easy to recognize. Telescoping. Telescoping is really easy if you have a series minus another series. That doesn't automatically make it telescoping, but that's something you should check first, right? Sometimes it's hidden. Sometimes they hide telescoping behind a factorable denominator, right? So if you're stuck, check and see if the denominator factors, and then if you can use partial fractions to rewrite it as telescoping. So look for those telescopings. All right, raised to the nth power. If you have the whole series to the nth power, you always want to use the root test, right? You can actually use the root test for geometric, and they work just fine, right? But no matter what, if you've got the whole series raised to the nth power, then the root test just gets rid of the n. Yes?
Alright, legit question, but on the test, will there be any way, I mean, okay, will there be directions on what specific test to use for what problem, or is it just do what you think is best?
Do what you think is best.
Okay.
Okay? Good. All right.
Wait, but.
If your series contains a factorial, that's almost an automatic ratio test. All right? So anytime you've got a series with a factorial, you want to apply the ratio test. I'm losing you, but don't worry, I'll get you back. Ratio test, remember, says if you take the limit of the n plus 1th term over the nth term, and that limit is less than 1, it converges. Greater than 1 diverges. Same with root. Here you take the nth root, and you take the limit as n approaches infinity. If the limit is less than 1, converges. Greater than 1 diverges. Right? So a lot of limits, right? Limit has to equal 0, or not be 0, right? R has to be less than 1. P has to be greater than 1 to converge. That one you just write out. So limit has to be less than 1 to converge. Limit has to be less than 1 to converge. Alternating series, the limit has to equal 0. So you remove the -1 part and you do the limit on the rest. It has to equal 0. Anytime you have -1 to a power, you should use the alternating series test. Until we get into power series, then you use the ratio test. But anyway, all right. So, someone asked me during first period today, they didn't believe that 1 over n diverged, right? It was really bugging them. And it is hard to accept that a series where the numbers are getting smaller and smaller and approaching 0, that the series doesn't converge. So we looked online and I found a video of a really cute proof of why it diverges.
Mine is
So-
cute.
Yeah, that's
Let me show you, right? So just take a second. Okay, this was done by a French mathematician, I don't remember the name of the mathematician, I didn't make a slide for it because we just did it today. But it was a French mathematician, something tells me he lived a long time ago because they didn't have a photograph, they had like a painting of the person, right? But anyway, here's what he said. He said, you know, if this is the series of 1 over n, right, just listing all the terms out, that okay with everyone? If we create a new series, and the series he created was, you just make each term the highest power of 1/2 that's less than or equal to each term in this series.
Every day?
Why don't we not lean back, and then we'll be okay. Are you okay?
Yep.
Is your calculator okay?
Yes.
Okay. All right, no more leaning back. All right. Okay. So, for example, so we're doing powers of 1/2. 1/2 to the 0 is 1. That's the biggest power of 1/2 that's less than or equal to 1. 1/2 to the first is 1/2, which is the biggest power that's less than or equal to 1/2. Now we need the biggest power of 1/2 that's less than or equal to 1/3. So that would be 1/4, because it's 1/2 squared. The next power that's less than or equal to 1/4 is also 1/4. Now we get to 1/5. The biggest power of 1/2 that's less than or equal to 1/5 is 1/8. It's 1/2 cubed. And then again, you'd have 1/8, 1/8, 1/8, until you hit the 1/8. Then you move on to 1/16, right? And you're at 1/16 all the way through until you hit 1/16. And then you move on to 1/32, right? And you just keep going. So what he said was, this series has to be less than this one. Because every single term in the series is less than or equal to terms in this series. And because, I know, it is pretty cool, isn't it? Then what he said was, if you take all of the fractions, there will be 2/4 and they'll equal 1/2. There, you'll see, there would be 4/8 and they total to 1/2. There's going to be 8/16 and they total to 1/2. There will be 16/32 and they total to 1/2, right? And so, and it's pretty cool, and it's really easy to show that that's true. So what happens is you're taking 1 plus 1/2 and adding 1/2 forever. So the series absolutely diverges. Yes?
So how come this mathematician can just say, okay, why don't we make 1/3 into 1/4 and so on?
That's
Well, he's just making up his own new series.
He's
not-
doing a
he's not-
direct comparison.
Yeah, and he's and very good, and I was just saying, he's applying the direct comparison test, because since this diverges, and this has to be bigger, then this has to diverge as well. If this sum approaches infinity, and this one's bigger, this has to also approach infinity. Right? So I thought that was pretty cute. So there you go. Now you've just proven
Redefine.
that the sum of 1 over n diverges. Right? There you go. Alright, so the last 3 tests are trickier. You've got the integral test, the direct comparison test, and the limit comparison test. Integral test you use when you have a very simple, easy, obvious integral. Not simple, but like, oh, look, it's a u sub, right? I can see it clearly, that kind of a thing. If it's fairly straightforward to integrate, then the integral test works. Remember, the integral test just means if the integral converges, the series converges. If the integral diverges, the series diverges. They match, right? Integral has to be taken from 1 to infinity. It's always an improper integral. You have to plug in an infinity, right? Okay, direct and limit comparison test. You have to come up with your own function. So, direct comparison test, you come up with some function that's always less or always greater than the other one. Greater than diverging diverges, less than converging converges. Limit comparison, okay. So, limit comparison you use if direct comparison fails, or if you just don't like using it, then use limit comparison. You come up with your own function, take the limit. As long as the limit is finite and positive, then they match. So So if one converges, the other converges, if one diverges, the other diverges. And I added ratio test here because sometimes ratio test works for a variety of functions. So if you like it, it's kind of a nice one to try. All right, so it's time to play match game. It's not really a game, but you know, here we go.
Oh, what do you want?
You can pretend it's a game. All right, so here's what I want you to do. In your pairs or your groups, I want you to take 4 minutes, and I want you to match a test to each series. All right?
5 is B.
I want you to match, and you don't have to actually solve or determine convergence, you just have to match. Now, you know you're going to have to determine convergence next, but for now, you're just gonna match, okay? There can be repeats, but not necessarily.
Your root test for today.
Yeah, no, and for
Do
5.
geometric for 5.
Oh, yeah. Wait, is that a pi or an n?
It's a pi.
Oh, sure.
Oh, shoot. You don't actually have to like do anything.
But you could still do a root test, dude. That's way easier. For 5, yeah, I can. Or less than 1.
I mean, you can do it either way, but
It's way
you don't
faster.
even have to knock out the n for a
Yeah,
Why would I want to do
a
1
geometric series on
No,
5,
sure,
on
sure, I'm not
5,
talking about this.
on 5, a geometric series, you don't have to do any work. You just have to determine whether pi over 6 is greater than 1. That
If
is
you have a
literally all
geometric
you have
series,
to
you're gonna
do.
want to do geometric
Yeah.
series, because you don't have to do any work, you just look at it.
Yeah.
But
Like,
you
if
could
you-
use
if-
root test, just fine. And if you like the root test, use the root test.
I mean, if I did geometric series, like, I would have to do 1 minus 1.
No, because we're just determining whether, but test, whether, you wouldn't necessarily, not if you're only determining whether it diverges or converges.
Divergence and convergence is like a root test. Yeah, I know it's pi over 6, which is less than 1.
Which is the geometric, test. For convergence and divergence, you didn't look at the sheet, did you? Look at the sheet. Look at geometric series, converge, diverge. Not what the limit is, look at what converge, diverge is. It is whether it is greater than or equal.
Trust yourself.
Would you do for number ratio test?
Well, I did that. Or you can just do the intern test and then go to infinity, so that works too.
You win.
Yeah, you can do it for both grants. They're more than
Because the
7.
factorial is the fastest. What's the
No.
factorial is the fastest. Exponential. So then that goes to infinity, which doesn't count. So you can just do an
Well, I
exponential.
probably did before.
So divergence. And then the last one, I feel like that's
No.
you could do an nth term. I mean, geometric. No, you can do geometric for one. No, but you can.
Direct comparison or
No, Shreyas, you don't have to like solve it, it converges.
Right, you don't have to solve it right now, you just
Well,
need
yeah,
the
I know. I'm
test.
just saying you can apply.
But is number 7 geometric?
No,
No.
integral,
Because that n is,
get that integral.
Yeah, okay, well, okay. There are multiple ways, but there's one easy way.
Yeah, you can
Anything-
negative and square.
I love you, son.
Alright,
You
let's
don't-
walk
you're
through the
like
answers.
9 out there.
Now, one of the things, there's a couple of these that have a couple tests, so when, once I show you the answers, there's gonna be some other, stuff to talk about. So number 1, oh, you know what, wait. What'd you guys get for number 1?
I said
Direct comparison is a great test to start with, but the direct comparison test actually ends up failing for this, and you end up having to use the limit comparison. Yeah. Alright,
why, Ms. Price, why can't you use n?
why can't you use the nth term test?
because it goes to
Because the
0.
limit approaches 0, so it's inconclusive.
Can you do that integral test?
You can do the integral test.
Alright.
Yeah, you could. Yep. Alright.
Wait, why does the direct comparison test fail for anyone?
Let's see, you would probably compare with 1/3n, right?
Yeah, diverges.
That, and 1/3n diverges, so you'd need that to be larger than
Oh,
1/3n, and it's
But
not,
it's
it's smaller.
smaller.
Okay,
So you switch the plus one to a minus one.
just change the problem.
Yes.
Uh,
That's what I do. Nobody
All right,
said
number
you
two, which test would you use for number two?
Alternating.
Alternating series, because you got a negative one to the end. Number three, which test?
Nth term.
Nth term test, very good. Number four?
Ratio.
Nth term or ratio, right? Yeah, ratio works great with factorials, but that one actually also works with nth term test. All right, number five,
Geometric.
geometric series or root test,
The root
right?
test is stupid.
Okay, number six.
Root test.
Okay, yes, I say the root test, and we all learned that in Minnesota you say the root test. So yes, the root test, right? Yeah.
What if I went to the route test?
The route test, all right, all right. Number seven, integral test. This is just screaming use of, right?
Wait,
Yeah, this is an integral test. All right, good. So, are you ready to try it?
I don't know.
Okay, so I want you to take the next 10 minutes. Take the next 10 minutes. I'm gonna give you about a minute a problem to determine convergence
But
or
I didn't write down
divergence.
what test to use, I just wrote the letter.
Oh, no. Now
That's
you're gonna
fine.
have to figure it out again.
Oh,
It's
it's so hard.
This class.
It's hard. Why are you singing?
Well, I've never watched any of them.
Alright. Let's get started on
I just had to. Refresh my memory.
Oh, okay. That's fine, yeah, you just
So for ratio, you have to do
no questions, right?
Yeah, and that's great.
So then once you know that it equals one.
Divergence for
Yeah, I was gonna say.
direct comparison.
Wait,
Are you actually working these out, or are you just kind of doing them in your head?
Why
Well,
not?
I remember what they were, like, number 4 was n factorial over 10. And yeah,
Just so you know, on your test, I'm gonna be looking more than just this, right? Okay. All right, on your test, I'm gonna be looking for mathematical justification for each one, not just the
Well,
answer.
like with number 1, how I wrote the integral. I did. The other one.
That's okay, I'm sorry. Just check in, see how.
For the end, test should be shown that we didn't.
I wanna see the
limit
limits of that as that approaches infinity. Yeah, guys, even if you're using the nth term test, I wanna see that you applied it with the limit as n approaches infinity of the series. Tell me what you get, so that I know that you know. Right? Oh, you wanna show me the sum thing? Sure.
Yeah, okay, so it's
Who was the word?
this is the
Okay,
yeah, so then,
I don't remember if that was a sure.
I'm pretty sure.
Okay.
So since that, and then we go into sequence.
Oh, no, you gotta do sum first.
Some sequence?
Yeah, it's sum sequence, not sequence sum.
Okay. Thank you.
Uh-huh.
There's so much nature.
Oh, I really,
Decorating.
yeah, I did it wrong.
Yep.
Let me try
There's
that.
so much
Okay.
room. Shells, tandem.
Okay, so for the first one,
Convergence.
so for the first one, you do the limit comparison test with 1/3n, and you get 3n/n + 1, which is 1. You could do this by the way, with 1 over n, right? You don't have to do 1 over 3n. You still get a finite positive number. So as long as it's finite and positive, they match, right? They don't just necessarily converge, they match. So since this guy diverges, this guy diverges. All right, for the next one, alternating series test. After, we've already talked about this before, when I first taught alternating series, I was a stickler to make sure that you knew that the series had to be positive and decreasing, and then the limit had to approach 0, right? After talking with Mr. Thomas, that whole proving it's positive and decreasing is really not necessary to emphasize. The main thing to really focus on is, does the limit approach 0 of the non-negative 1 term, right? Okay, so that's all you really have to check for alternating series. You might want to just mentally take a glance and make sure it is positive, right? But anyway, so yeah, so then the series converges based on alternating series test. All right, for number 3. Number 3 is a very nice nth term test. Right, if you take the limit as n approaches infinity, you end up with a third. If it's not 0, it diverges. Right, limit is not 0, it diverges. All right, so everyone take a few minutes now and do 4, 5, and 6.
It's 73
Is it really?
73?
No, wait, it's 73.
Is it 73?
Are you kidding me? 70?
Are you serious?
Why does everybody think I'm lying?
Why does this happen?
That does not sound true. Look.
It's 66 degrees right
You might want to update your source. My phone says
Your phone is stuck at like 4 this morning.
My phone is stuck at
now it says 70.
All right.
66.
So anyway, let's work on problems 4, 5, and 6.
It says the lowest 40 though.
Yes, see? I'm not lying.
My phone says it's 73.
I remember spring break too.
Oh,
I think I wanted to.
okay, well,
like that's reasonable.
hey, it's 73 degrees outside. It's 73 degrees outside.
Yeah, I know this.
Yeah, see?
I felt
See? He believes me.
Guess you just went outside right now.
Will Silver.
I can take that out.
Everyone should be making sure you get 4, 5, and 6 completely done.
Of course.
This is your practice time. Your test score, not mine.
Did the first take up 500 divergence?
Wait, why aren't you taking the test for us?
That's the one. Yeah, that's the one diverges for P test.
Are you sure?
Diverges for geometric, yeah.
Yes, I'm looking at it.
Keep making up for
I know. It is hard to keep them all straight. Yeah. Getting the limits all straight, like does the limit have to equal 0, does it have to be positive, does it be less than 1, does it have to be greater than 1? You know, those are tricky to get them all down.
I didn't actually know it was 73 degrees out, but that's actually pretty sick.
Sick meaning good.
Well, or is it gonna get a fever because it's so hot outside?
It's sick, just
Okay.
like you say radical in media.
Alright, so the first one, you could just do nth term test,
Wait,
right?
did you use the weather app?
I did ratio test. Alright, that's enough about the weather. Alright,
I am
So,
really sorry about it.
I did ratio test, but you could certainly do nth term test and be done, right? Nth term test, 1 second, you're done. Because the limit approaches infinity, because factorials grow faster. Alright, number 5 is what kind of a series?
Geometric.
Geometric. Is pi over 6 less than or greater than 1?
Less than.
It is less than 1,
So it could not.
right? Therefore it converges. This guy, which test do we use when everything's raised to the nth power? Root test, right? So we take the nth root, and if the limit as n approaches infinity of the nth root of the absolute value of the function is less than 1, it converges. See how easy it is to remember, right? And then if, of course, if the limit as n approaches infinity of the nth root of the absolute value of the series is greater than 1, it diverges, right? So for this one, it's less than 1, so it converges. Okay. All right, take a minute, do the last one, that number 8 was just us messing around with this first period. Goofing off with series convergence, right? Yes?
Isn't, the root test basically just geometric, because of the R?
It is, the geometric series test actually falls underneath the umbrella of the root test. The root test can be applied to more than the geometric series test, yes. You don't even really need the geometric series test. You do the root test alone. But, who doesn't like the geometric series test, right?
Do we have to, since it's an improper integral, we have to do the limit of the approach?
That is correct.
Okay.
Now, I need to warn you on the answers. I did U sub and changed my limits to U values.
Oh, yeah.
But, you could just convert back to X's and use the X values, it's fine. I would just let U equal negative n squared. It's just a U sub. Let U equal, whenever you have e to a funky exponent, always start by letting U be that exponent. Let U be negative n squared. No, lots of that integrals. In a few days, we're gonna be doing integrals and derivatives.
Together.
It'll be fun, because you guys all like derivatives. Not in a few days now.
Yeah, I'm gonna quit and I'm not gonna do some posts. I can leave her. We're just downgrading a little bit. It's like going from an iPhone 6S to like an iPhone 5S. Or just an iPhone 6.
You're doing great.
Nah, I'm with it when I was over in simple phone like iPhone 6S, like a 4. It's like an iPhone 3S. It becomes a real BlackBerry.
Yeah.
Dude, when I had this BlackBerry, you dropped it down the stairs
If you
one
get a
time.
regular
It's suddenly Or I remember when my cousin got like the Google phone when smartphones were like a new thing.
Did you get
Like that, like touchscreen smartphone.
Limit equals 1/2.
And we all just sat there and played bubble.
So remember for the integral test, the function is supposed to be positive and decreasing. Didn't really check that, but I will tell you, if it's not decreasing, it's gonna diverge anyway. But anyway, so we take the integral and we do a little U sub. If you get an answer for the integral that's not infinity, just some nice little finite number, that means the integral converges, which means the series converges, right? And that's what happens
But
here.
not at that value.
So, but not at that value. Yes, good point. So, the value of the integral is not the same as the sum of the series. But it does tell you that it converges. That's good, but I will still be grading your work. Yeah. So if these problems, say these problems are 5 points each, then you'd get probably a point for the correct circled word, and then the other points would be for your justification.
Wait, but isn't the most important part of this is determining it whether it converges or diverges?
For me, the most important part is, did you actually learn the math behind it,
Well,
right? Not can you circle the
The
right.
most important part is determining whether the converges or diverges. But the key
Mathematically,
word-
but not
the
as a
key- no,
student.
the key word is determine, not guess whether it converges or diverges.
Right,
You
right.
have to determine.
I like that, appropriately determined, okay. So, this was just us showing that that last problem, which was an integral test, could also have been done using the root test. I honestly
No,
wasn't.
actually I don't.
Did you really?
Like, yeah, I was like, my school's.
I hate runners.
Oh,
In
did you try the root test?
extracurriculars,
figuring out which one you guys.
Right,
academic.
yeah. anyway, yeah, so if you do it using the root test, remember you're taking the limit as n approaches infinity. The nth root of n, you can prove that this is 1. It's in your book, there's a whole little thing on it.
We have to do that.
You have to do it in your homework. There you go. So in your homework, you have to do that the nth root of n and prove that it's 1. So anyway, so this is 1, you get 1 times 0, which is 0, essentially. Alright. So, alright, it's time to do a Kahoot.
No.
So here's what I want you guys to get out either a cell phone or a laptop.
You can just go to
Right, so being redundant. By saying fun